Okay, we have a straight, stiff wire of length 1 meter, which has a mass of 25 grams, and I tell you that it's suspended in a magnetic field, and I give you the magnitude of the magnetic field, which is 0.75 Tesla. The wire is connected to an EMF, meaning that it's connected to a power source, so current is flowing through this wire. How much current must flow in the wire and in what direction so that the wire is suspended and the tension in the supporting wires is 0? So let's draw a picture. So I've drawn my B field, which is B is equal to 0.75 Tesla. I've drawn it so that it is coming out of the page. I've indicated the length of the wire in the magnetic field is 1 meter. I'll tell you the mass is going to be 25 grams. In order for there to be no tension on the strings, the force, the magnetic force, has to be upward. Okay, because the tension, the weight of the object is pointing down, so the magnetic force needs to go up to balance out the weight of this object pulling on the strings. So if that's the case, right-hand rule, my current should go to the left. Okay, so the question that asked what direction should the current flow in order that the wire is suspended and the tension in supporting wire is 0, the current needs to flow to the left. Okay, so the question that I now need to answer is how much current must flow. So I is current and the units need to be amps at the end. So the concept is force on a current carrying wire. The relationship is going to be F is equal to I, which is the current, L, the length of the wire, sine theta, B, where theta is going to be the angle between the current and the magnetic field. So what is known is the length, the mass of the object, and B. What is unknown is the current, which is what I'm looking for. So my plan is to start with the equation that will allow me to answer the question. F is equal to I, L, sine theta, B, where I know that L is perpendicular to B. L is the length of the wire, and the direction of L is going to be the same direction as the current. So L and B are perpendicular to each other, so sine of 90 gives me 1. So I can rewrite my equation as F is equal to I, L, B. And I can solve this for I, because this is what I'm looking for, how much current is flowing. So I is equal to F divided by LB. So I know what L is, that's the length of the wire, and I know B, which is my magnetic field. What I don't know is the force that the magnetic field needs to apply. But I know that that force has to be balanced out by the weight of the object, W. I know W is equal to M times G. Now I know the mass, and I know G, which is acceleration due to gravity. It's a constant of 9.8 meters per second. So I know what W is. Since I know what W is, I know what F is, and I can solve my equation. So I can execute the plan, and again, starting with W, solve for W. Once I have W, W is equal to F, so I can plug that into my I is equal to F over LB. Plug in those values, and I get an answer of 0.33 amps. So 0.33 amps needs to flow through this wire in order for it to balance out and no forces are placed on the wires.